build a map application based on STL data structure and graph search algorithms, performing various functions like positioning and route planning. Some main features are included in this project. And my partner Tianyi implemented those parts, which are autocomplete the location name and find the place coordinates, calculate the shortest path and cycle detection and topologic sort. And I implemented the 3 algorithms for traveling children part, which are brute force, 2-OPT algorithm, and genetic algorithm. Next, Tianyi will introduce the parts that he implemented.
Okay. First, let me introduce the autocomplete. It takes the responsibility of search the names of all nodes, and it finishes the prefix search, and it will return a list of all of the possible names. For example, here we have a ST as the input, and we can get the Starbucks student union STU as the possible answer. And next slide. And here is the example. And go. And the second function is get position, and we will have a name of some position, and then we will get the latitude and the longitude. And if the location doesn't exist, it will return a -1 and -1. At the meantime, if it was found, the location will be marked on the map as a read point. As we can see from the example here, we want to find the target, and we can find it was exactly as in the map as the read point. And the next part is the calculate shortest path, and we finish this on 2 algorithms. One is just digit graph, and another is Bellman fold. And first is the digit graph, and we did not take much time to introduce it, and we can just see from the example that it finished the job. And the next page is the example test. Yeah, and another algorithm is the Bellman fold, and we can also see here is the result of our algorithm, and we can also see that we find the path. Next page. Yeah, and the next job I finished is to detect the cycle detection. Next. And we just use the DFS to finish this job. And we can see here is example that there is no cycle we can find. And the last job I finished is the topology sort, and we have a lot from it in the lecture, and I just skip it. And then is my partner's job.
Okay, I was responsible for the implementation of traveling children problem. This section is based on traveling salesman problem. A complete graph is given, and the shortest route that covers all the locations exactly once and goes back to the stop point will be found. And first of all, it's brute force. The high level is that using DFS search and permutations, getting all permutations of the input string vector and calculate each permutation's path distance and return the shortest one. This is the result of this algorithm, and the time complexity is big O of n factorial. Then is the 2-OPT algorithm. The high level is that set a maximum number of iterations must count, x count, initialize the count to 0. The step 1 is assuming shortest route like A to B to C to D to E to F to G. And the step 2 is selecting 2 nodes that are not neighbor, swapping them and get a new route, like swapping B and E. And the step 3 is if the new route is shorter than the previous one, then set it to the current shortest route and set the counter to 0, and then return to step 2. Otherwise, counter +1 until it's larger than the max count. When the count hits the max count, the current shortest path is the shortest path. And this is the result of this algorithm. And the time complexity is big O of n power of 2. And then is a genetic algorithm. It's a little complexity. Genetic algorithm is inspired by simulating the process of biological evolution, and the algorithm is designed to replicate the natural selection process to carry generation, and it includes several steps like initialization, phyllis evaluation, selection, recombination, mutation, and replacement. And this is a mapping between the genetic problem and traveling salesman problem. And this is the result of this algorithm, and the time complexity is O(n) log n. So, and finally, in this project, we learned to use STL data structures, graph search algorithms, like Dijkstra algorithms, and to build a mapping, calculate the distance between 2 locations, and display the shortest route for traveling children. And also, this class helped us widen and deepen the knowledge of C++ and various practical algorithms. Thanks so much to Professor and TAs. We learned a lot from this class.